Well, hello everyone, and welcome to Will It Blend, a presentation where we're going to be looking at some techniques where we can learn how to fillet and smooth pretty much anything in SolidWorks. My name's Andrew Lowe. I'm an industrial designer with the Damani Group. We're a full-service product development consultancy based just outside of Chicago in Aurora, Illinois. In the first half of this presentation, we're going to take a look at the fillet tool, understand what it's doing in the background, and some ways we can add tricky and problematic fillets to our models. In the second half of the presentation, we're going to switch gears a little bit and look at some ways we can blend dissimilar shapes into each other to create some really nice aesthetic results. So I have two models on the screen. I have a model that I added fillets to, and then I added a model where I added fillets but also added a blend. And while it's not immediately obvious in this view, the actual model that has only added fillets applied to it actually has this big pucker in the middle. And that's where I have created this big blue face, which is a blended face. So from the side, if you rotate the model a little bit, you can see the difference. So the blend looks like what the corner should be, whereas the fillet result actually has a pocket in the middle. And the reason for this is the geometry that's being used to create the section. The fillet tool relies on bridging transition with sections of an arc. So fillets are inherently arc-based. However, in SolidWorks 2014, they did add the ability to have conic fillets, which were based on sections of a cone. However, because I work at a consultancy, I have to use whatever version of SolidWorks that my customer is using. So I actually haven't had much of a chance to play around with the fillet tool in SolidWorks 2014. So we won't be able to address that simply because I don't think I'm a reliable source. I haven't had a chance to actually play with the tools. So while the example with fillets, all the transitions are based on arcs, blends involve shapes that cannot be described simply with arcs, and they're usually spline-based transitions. And for those of you out there who are wondering about the setback fillet and how it might handle this corner, well, I applied the setback fillet to this corner, and you can see the results speak for themselves. So sometimes we need blends on our models to make things look right. The example on the left has fillets applied to the corners, whereas the example on the right has had some blends added to the model. And you can see the difference in the quality of the highlights on the model. The light appears to flow much more smoothly on the model on the right, whereas on the model on the left, it's almost possible to see the actual fillet features that we applied in SolidWorks. We're going to be looking at this one particular part several times throughout the presentation. We have examples of a fillet. We have an example of a blend where we blend a convex fillet into a concave fillet. We have an example of where we blend a fillet out into this cylindrical shape here. Finally, we'll look at ways we can create fillets manually using some of the surface tools. And who am I? Well, I work as an industrial designer at the Damani Group, and I can't let CAD dictate design decisions to our clients. If SolidWorks isn't going to add a feature, I can't cheat by putting a 0.24 fillet on an edge when that fillet needed to be 0.25. I need to be honest to our customers and provide the correct design intent. I don't want to let SolidWorks dictate what my geometry looks like. I need to create the geometry that the product wants to be, not what the CAD package gave me. So let's begin by looking at fillets and understanding what the fillet tool is doing in the background when we apply a fillet to an edge. So I would like to fillet this edge here, highlighted in red. But if the fillet tool were dumb, we might get something like this, the blue face, whereas we can see in the little diagram here, it actually created an undercut on the two cones. Luckily for us, the fillet has a lot of intelligence built in. So what the fillet tool is able to do is automatically extend faces on the model, giving somewhere for the fillet to end. It extended these two red conical portions of the model and was able to give the fillet somewhere to end along this edge here. And if the fillet tool wasn't able to extend faces, when I went to fillet this edge, I once again might get something like this, where the fillet actually extends off the edge of the part. But because the fillet tool is smart, it extends the planar face and gives the fillet somewhere to end. And when we apply the blue fillet, there are no faces available to end the fillet. However, what the fillet tool is able to do is actually taper the size of the fillet, not the radius, but the actual size of the face. And so the radius of the fillet, it's constant all the way along here, but it's actually bridging a smaller and smaller section until it bridges nothing at the end where the fillet terminates. So who's seen one of these error messages before? Show of hands. Pretty much everyone in the audience, and that's why you're here today, to figure out ways you can get these error messages to go away and to add the fillets to your models. So despite these cryptic error messages, the fillets are probably failing for one of two reasons. First one is that the software might be unable to extend the faces along the path of the fillet, allowing the fillet to terminate. Or it could just be that the fillet is actually too large for the geometry. It might only be one small portion along the path of the fillet, but if it's mathematically and geometrically impossible to add a fillet that's too large, then the software is going to give us that error message. But there is some hope. We have an idea that the fillet tool is failing because it doesn't have the right faces to work with. So what if we gave some techniques to actually give better faces to the fillet tool to help terminate these tricky fillets? So here I'd like to apply a 1/4-inch fillet along the highlighted edge. However, SolidWorks is unable to add the fillet at the desired radius. So I'm going to jump into SolidWorks here. And here I have a section of a model we were working on for one of our customers, and I had to cut it away and bring it in as an imported body just for confidentiality. And I'm going to fillet the corner of the model first, this corner here. So this is where I was at in the last slide, and I'd now like to add a 3/8 fillet to this edge here. I'm going to do that, and I have the tangent propagation turned off. This way the fillet's not going to try and wrap around this edge. What I'd like to do now is add my fillet, and I'm going to add a 1/4-inch fillet along this edge. Now I don't see the preview. If I don't see the preview, odds are I'm not going to have the fillet complete. And we'll click OK, and I get the error message saying that the radius of the fillet is too large to fit the surrounding geometry. So what's happening here? Actually, first, who has been guilty of doing this? Oh, still doesn't work. Maybe 0.23? Nope, no fillet. 0.22, oh, we get the preview. So it looks like this fillet would be successful at 0.22, but the design intent of the part, it calls for a 1/4-inch fillet. Now, I'm not going to let the software dictate to me saying, well, software says I can't add a 1/4-inch fillet, but I'd like the 1/4-inch fillet. So I'm going to make a guess. Well, I've been doing this long enough to know that the faces in this corner here are tricky for SolidWorks to try and figure out. It's having a problem trying to figure out how to apply that 1/4-inch fillet along these faces here as this edge tapers to nothing here because it comes tangent on this face. So I'm going to test that hypothesis by cutting the corner away from the model. So I'm just using a simple cut extrude. And then what happens when I go to add my 1/4-inch, not 0.22-inch fillet? Preview. So I've been able to add the fillet to the model. But you may ask, well, now you have at the corner cut out of the model. How are you going to resolve that? Let's just suppress this guy. Well, I'm going to use the delete face tool to do that. And I have the corner back in the model. The way this is working, delete face has 3 incarnations. It has delete, delete and patch, and delete and fill. And we'll be looking at all the different incarnations throughout the presentation. But the delete and fill option, what this is doing is removing the highlighted faces from the model, and it's actually putting a patch or a new surface over top of that corner and allowing the corner to be successful. So the way this is going to work, I'm going to pick the 3 faces. I'm going to select delete and fill, and I want tangent fill turned on. This is going to ensure that the resultant patch is tangent to all the surrounding faces. So we'll click OK, and I now have my corner successfully repaired. I was able to add the 1/4-inch fillet to the model by removing the tricky portion of the fillet path and then replacing that portion with the delete face tool. Now some of you may be wondering why my model edges look a little bit different. It may be a little bit hard to see in the back of the audience, but I have an option turned on under display selection called Part Assembly Tangent Edge Display as Phantom. What this is going to do is put a dotted line on all of my tangent edges, so that way I can look at the model and instantly know which edges are tangent and which edges are not. For example, if I turned off my tangent edges, which I believe you can also get to under View Display. So this is the traditional view that you see in all the marketing demos, and I'm sure a lot of you are working with. So if I change this surface to turn off the tangent fill option, it looks pretty good. I can't really see anything wrong. But if I was to turn those edges back on, those phantom edges, you'll see that the patch isn't actually tangent. So I like working with this. I used to thought it looked weird, but now I can't work any other way. So that was turning off the tangent fill option and having that surrounding patch not be tangent to the faces. So to recap, the correct design intent was a 1/4-inch fillet, but I was unable to add it at the desired radius. So I identified potential fail points along the fillet path, and here it was where there was a complicated set of faces that the software was unable to resolve the fillet with. So I cut the area away from the model, add the radius at desired value, and then I can use the delete face command with the delete and fill, tangent fill option checked to successfully patch over the corner. It's kind of like using sandpaper to just gently smooth everything out in that corner. So here's the tangent edge display. I invite everyone to try it out. Like I said, I used to thought it looked goofy, and now I can't work any other way. So other ways we can have fillets complete is to rearrange the order that the fillets were applied in. So let's open up this other model. I'm going to start the exact same part, but instead of filleting the vertical corner first, I'm going to apply this large fillet, followed by the 1/4-inch fillet, which added no problem. Finally, 1/4-inch fillet on this edge, and then a slightly smaller fillet here. So this was the fillet that was actually causing problems with my previous example. And sometimes you're able to go in and rearrange your feature tree, but other times you might be dealing with imported geometry or making that change just might be impossible based on where you're at in terms of your parent-child relationships. So as a rule of thumb, larger fillets go first and smaller fillets go second. The smaller the fillet, the better chance it has of being able to resolve itself on complicated faces. So by able to rearrange the order of the fillets, I was able to have the fillet complete. We can also try turning off tangent propagation. I'm not entirely certain how this works, but on certain models, it does, and you'll be able to add a fillet to the model. So here, I'd like to apply a 1/4-inch fillet to this edge. If I zoom in here, I actually see I have a lot of faces in here that could be problematic for the fillet tool. So I'll go to add my fillet, 1/4-inch. Now I see it thinking for a while. This is probably a good indication that I'm not going to have the fillet complete. I don't see the preview. I click OK. Thinks for a little while, and it says failed to create fillet. What I'm going to do is turn off tangent propagation and pick all of the edges along my fillet path. And I see the preview, click OK, and I was able to add the fillet to the model. So like I said, I don't know what's happening in the background when you turn off tangent propagation, but sometimes it is a way of getting a fillet on the model. The only downside is you have to manually pick a lot of the edges along the fillet path because the tangent propagation is going to automatically select them for you. The other technique or tool we might be able to try is the face fillet. So the face fillet pops up in that error dialog box where it says, or try face fillet. And face fillet works a little bit differently than the standard constant radius fillet tool. So I'd like to fillet these two internal corners. And I got this geometry from a client. We couldn't go and change the original master models that their design team had created. We were responsible for detailing some of the internal features. So I'm going to add my fillet at 10 millimeters. I'm going to fillet this edge, and I'm going to fillet this edge here. Click OK. Well, I got my one fillet, and I have a portion of the other fillet. So the fillet is 10 millimeters, but I want the correct fillet. I want to fully round the corner. I don't want a small portion of the fillet. And the reason that fillet is failing are these small faces I've highlighted in green and yellow. So SolidWorks is actually using the wrong face to end the fillet. It's doing exactly what the fillet tool is supposed to do, but it's not giving us the correct result. The way we can work around that is using the face fillet tool. We can get to the face fillet tool under the face fillet option, and instead of picking edges, I'm picking faces on the model that the fillet's going to be applied between. So I'm going to pick this face here, and I'm going to pick the second face. Note I'm not going to pick these small junky faces in the corner. What the face fillet tool is able to do is actually bridge over those poor faces and apply the fillet directly between the required faces in the model. One downside of using the face fillet tool is that you have to add one fillet at a time. Even though I can pick multiple sets of faces, I only can add one fillet at a time. So you would have to use multiple face fillets. But a lot of the time, if you can get that one fillet out of the way with the face fillet tool, the standard fillet tool will be able to add the rest of the fillets to the model once you've gotten that tricky fillet added. The face fillet tool is able to bridge the small faces by applying the fillet between two faces in the model instead of an edge on the model. Another example of the face fillet tool is adding fillets to models where the constant radius fillet tool just can't figure out a result. So this is an approximation of an area of a part we were doing for a client. And I'd like to round off this edge. It doesn't have to be particularly controlled. So if I go to add a normal fillet and 10 millimeters. So the software is unable to add the fillet because it can't resolve how it's supposed to terminate the fillet. Is it supposed to use this face or this face to end the fillet? But because the face fillet tool is applied between faces and not edges, I can now bridge the two faces in the model with the face fillet tool. Finally, I can add my standard fillets, the constant radius, to complete the filleting on the model. The face fillet tool has a lot of power in it just because it's able to bridge over faces and ignore things in between them. So we're going to take a look at fillets across the parting line. Sometimes when you add fillets to a molded or cast part, you can get these sloppy-looking transitions where you prefer to have a smooth, clean transition between this part of the parting line and this portion of the parting line. So here I have my fillet across the parting line. I'll unsuppress that to show you what it looks like. You can see here it's really sloppy. It's going all over the place. So suppress this fillet again. And what I'm going to do is split the part into two halves so that way I can add fillets to the two halves separately. The way I'm going to do that is here I have a sketch, correct normal too, that I converted the edges of the parting line into the sketch. The sketch is just on the front plane. I'm just using the default planes here. Then I'm going to use the split tool. And what the split tool does is take a solid body and instead of cutting it, splits it into two. The split tool can use sketches, it can use surfaces, and it can use planes to split the model. So I now have two solid bodies, and we can see in the solid bodies folder where I had one solid body. I'm going to hide the solid body on the top. And I can now add my fillet. And because it doesn't have to worry about the faces on the top half of the model, the fillet is much cleaner. I have a nice smooth transition between this portion of the parting line and this portion of the parting line. But you may ask, well, now my model's cut in two. How can I put it back together? Well, that's where the combine tool is used. So the combine tool I can use to add the two halves of the model together. But if I zoom into this corner, you'll see that by adding the fillet to the top half of the model and the bottom half of the model separately, I actually have this new sliver face in the model. Now, depending on the tolerances and your level of fidelity in the model, if you're making a big sandcast part, this might be perfectly acceptable. However, if you really want to have clean geometry, there's some ways we can work around these small sliver faces. So to recap, we can use split part to stop fillets anywhere on our model. It doesn't necessarily have to be to model a clean parting line. If we need to have a fillet abruptly stop somewhere, split the part, add the fillet, and then use the combine tool to put the two halves back together. Here we use the combine, and we have a nice clean parting line. Here we have another failed fillet. And this is where the edge tangentially ends. So this edge actually becomes tangent to this large cylindrical face. So here's the starting point we just were. We cut the part in half, we added the fillet, and now we have this smooth, clean transition. And I'm going to add this fillet and then manually build this little corner here so I don't have the sliver face. So just like we cut away a portion of the model in the first example, I can extrude a block into the model to help end this fillet. Now when I apply the fillet along this set of edges here, it can cleanly stop at this planar face. What my sketch looks like is just some lines made coincident to vertices in the model. So this is the fillet that fails. I tried to apply it at 1/4 inch. No success. See the red X in the tree? Here I was able to successfully add that fillet because I had this nice clean face that the fillet can stop at. But I now need to figure out a way to resolve this corner. I can't leave this blocky shape here. And that's where the split line tool comes into play. What the split line tool can do is take faces on the model and divide them and generate new sets of edges. So this edge didn't exist before the split line feature. Oh, it looks like I was a little sloppy and didn't fully define this sketch. But this sketch has a spline that's made tangent to a helper line, so it's a vertical or horizontal when it contacts this edge here. And I've made it tangent to this spline or this model edge here. Let's just get rid of errors so we don't see those the rest of the presentation. So what I'm doing with the split line tool is adding new edges in my model to isolate an area that I'm going to blend back into the model. Previously, we used the delete face tool with the delete and fill. Now I could do that here with the tangent fill option. And what it's done is actually it's not entirely tangent to this edge. And because this is a cast part, let's run my draft analysis from the top plane. We'll see if we zoom in, we actually created an undercut right at the parting line because we were trying to make the face in green tangent to the face in red, where the two faces are actually coming together like this. So what we do in this situation is just delete the faces from the model. So I deleted the faces from the model, and I've changed my system settings to make open surface edges red, so it's a little easier to see on screen. And we'll see before I had a solid body, and now my surface body, I have one whole surface body, where I've deleted these faces from the model, and you can actually kind of zoom in and see that it's hollow. We're going to patch this gap using the surface fill command. So what delete face with the tangent fill option on is doing in the background is actually automatically deleting the faces from the model like we just did and applying a surface fill over the patch. However, it sets every edge of that surface fill to be tangent, where the edges on the parting line I'd actually like to be contact. So a shortcut for making these selections is right-clicking one of the open surface edges and select Open Loop. What that's going to do is go around the perimeter of that opening we made in the model and grab every single edge. I can then apply tangent to all of my edges. And as a rule of thumb, the edges that I want to be contact, especially if I only have one or two of them, I'm going to click that one first. Because whatever edge I right-click to select Open Loop will show up first in my drop-down here. So I'll select the two edges, make them contact. And we now need to actually merge this surface fill back into the model. And this can happen automatically within the surface fill command. I need to make sure the merge result option is on, which knits the surface into the model, and try to form solid, which what takes our solid or surface body and turns it into a solid body. So if I have that off, everything looks like a solid model, but you'll see my surface folder still has the body in it. It's because even though it's fully closed and watertight, it doesn't have any physical mass to it. It's simply a hollow shell. So by turning on try to form solid, I'm back into my solid model. So for those of you who are a little apprehensive about surface modeling, you're only creating a surface model for one feature. It's not too bad. So to recap, we're going to create new faces in the model so that way we can cleanly end fillets. We can use split line to generate new edges on our model to create our blend areas. We're going to use delete face to remove those faces from the model. And finally, on situations that have both mixed contact and tangent requirements, we have to use the surface fill. We want to make sure that merge result and try to form solid options are turned on. So another example of creating a manual fillet at the parting line, where we've generated that small sliver face. So here I've split the part into two. You see my two solid bodies. And I'm going to apply a variable radius fillet, and I'll zoom in on the corner. And you'll see once again I get that small sliver face. So the way we can resolve this is by manually building the fillet using surfacing. So I need to define an area for my fillet to live in. And I'm going to use the split line tool for that. And here I have a sketch on the default top plane. And I've converted this edge and this edge of the model into the sketch, and I've applied a standard sketch fillet. And this allows me to dimension the top of the variable radius fillet. So I now have the top of my fillet defined, and I need to define the sides of the fillet. Just like the fillet tool generates new sets of edges on its own, we have to manually create these edges when we're building these fillets by hand. So I have my first edge, my second edge. You can now see almost an outline of what the fillet looks like. And my final edge is the bottom edge. So I've now outlined 4 new edges that my fillet's going to live between. So I use delete face again to delete that from the model. Then I'm going to use the boundary surface tool or surface loft, your choice. I personally prefer boundary, to build a new face on the model. Let's just walk through this together. So in direction 1, I'm going to pick the first edge and then the second edge. You see we have a surface running between them. Direction 2, I'll pick the top edge. Finally, the bottom edge of the model. However, there is one thing we will have to do. We want to ensure that the fillet is tangent to the side faces of the model. So I need to grab these little drop-down boxes and change the end condition to tangency to face. This is going to ensure that the fillet is tangent to the face highlighted in blue. I can also select them in the feature manager and select tangency to face from this drop-down. The boxes do the exact same thing. So I now created my new fillet face manually, but I need to join it into the model. You'll see those red open surface edges. So that's where I need to use the surface knit command. What surface knit does is take 2 faces on the model, or take surfaces and join them together. So I've selected the main surface body, and then the surface knit. I need to make sure this try to form solid options on, just like in our surface fill, so I don't end up with a hollow shell. Finally, the last operation is to combine the model back together. And some of you may notice that there's actually a second parting line to form the inside of this part, this large slot. So when this part was cut into half, the split was actually far different than where the parting line was. But look what happens to these edges when I hit combine. Combine takes the split edges and joins them back together, so that way I have the same geometry I had before I split the part. So to recap, sometimes if we want really clean geometry, the cleanest possible geometry, no little sliver faces, we need to manually build these transitions. So we're using the split line tool to define the edges of our fillet. We're using a boundary surface or a loft to fill or to patch over and to create that new fillet face. Finally, we're using surface knit to join it into the model, and the combine tool to put the 2 halves of the model back together. So sometimes the fillet tool can get us almost what we need and get us a lot of the fillets, but we might want to optimize some of the fillet intersections. So on the model on the left, I've only used the fillet tool, and you can clearly see the fillet faces. Here's a fillet face, here's a fillet face, here's a fillet face. Whereas on the model on the left, I've used the delete and fill tool to create some smoother transitions at the corner. So depending on the order the fillets are applied in, you'll either get a smiley, where the fillet kind of smiles up, or you get the frowny, where the fillet dips down into a frown. And these are very scientific and accurate terms, the smiley and the frowny, but just good ways I found to actually explain these 2 terms. So for parts that have high aesthetic requirements, sometimes the fillet tool can create awkward corners. So the way we can resolve these is once again with the split line tool. If you look at my split line sketch, I just have a series of line segments that I've made coincident to the end vertices of the fillets. And what this is doing is giving me more area to successfully blend the fillets in the model. Here on this one, I needed a second split line from the top plane to fully define a new boundary. And now using the delete face tool with the delete fill, I have much cleaner edges on my model. So before, after. So sometimes we can get most of what we want with the fillet tool, and then we can use split line and delete face to help clean up some of those awkward corners. And if you were to section the model through that fillet area, the smiley actually adds material to a model, and the frowny removes material. Whereas I like to say the blend is kind of Goldilocks. It's just the right amount of material on the part. So here we're using split line and delete face. You can see the area for the blend highlighted in red. And so here I have the same model with fillets and then with blends with a high surface finish, very reflective, and I've applied some very bright lights to it. And you can go back and forth and, show of hands, better or better. So sometimes the fillet, this is an example of where I'm going to model the geometry explicitly. Just because this is the result the software gives me, I actually want the result like this. So I'm going to go in and do a little more work so that way I have the geometry exactly as I want it, not what the software is giving me. So another solution is instead of using split lines, we stop the fillets at the corners with these big, large blocks that we can extrude into the model. Then you can use delete face to remove the faces of the blocks from the model. The downside of this is that you don't know how big the blend area needs to be until the fillets are applied. It's kind of hard to see in this image, but the blocks are actually much larger than the area the blend needed to be. So the light is actually, the reflection is dipping down a little bit because the blend face is kind of polluting our face where it should be nice and planar. It's actually now a kind of weird surface spliny form in here. So this technique is actually more stable because you're relying on blocks that are extruded in the model and not making sketch relations to vertices in the model. However, you need to be careful and dial in the size of those blocks to get them as small as possible so you don't have the potential of polluting your nice clean faces on the model with blend faces. So now that we've taken a look at some filleting techniques, we're going to take a look at some ways we can blend different portions of our models together. In the first example, I have a convex fillet here, and it's blending into a concave fillet. So somewhere around here, it probably is becoming perfectly straight. And this is a part I remodeled. It was inspired by a customer's part, and it was something that was originally designed in either the 30s or 40s entirely on paper, where it must have been nice for the draftsman to specify a fillet there, another fillet there, and have someone else figure out how all these fillets are going to flow into each other. But in the days of CAD, we need to explicitly define what our models look like, so we're going to look at a technique we can use to get this face into the model and to blend the convex fillet into the concave fillet. So you've seen this model before, and we know we can stop fillets, so I'm going to add 2 blocks into the model to stop the fillets so I can get as much of the fillet as I want, or as I can. So by adding these blocks, I can now add most of the fillets into this area. I need to use the split line tool again to split out the top edge of my blend. Here I'm using a spline. It's your choice. The spline can be adjusted by, didn't like that. Should be able to just drag the handles. The other option would be to use a series of lines and arcs. Sorry, this isn't my default setup, and I need to figure out where everything is again. So here I could start with a tangent arc, or a 3-point arc, and then I'll continue sketching some segments. It all depends on how much control and dimension you need to be able to add. The key things to remember is that you want to make the start and end of your transition tangent. So this arc is tangent, and finally, I think this is probably going to over-define, but I need to make probably these tangent too. I might get it. Will I get it? Yeah. So here I can go in and add some dimensions and fully lock down this shape. I could sketch it out with lines and arcs. I just use a spline for simplicity in this example. So I now need to do a little bit of cleanup work. And we're going to use another incarnation of delete face to do that. See this big block in the model? I'm not going to use a cut, but I'm going to get rid of it. And I use delete face with the delete and patch option. So what this is doing is I'm picking faces I no longer want to have in the model. These 3 faces of this block here. What the software is going to do is extend this face out and extend this face back to meet it. And I've now removed my faces from the model. Yes?
What's the difference between delete and patch and delete and fill, and when would you use one versus the other?
So delete and patch is revealing information that already existed in the model. So these faces were already there. Delete and fill is creating a brand new face in the model. So delete face can be really useful. For example, say I had another extrude in my model, and it actually went a little bit too far, but there was no way I could resolve that. So I had this nasty little cut in my model created by another feature that actually did something useful, but it created a little bit of junky geometry somewhere. So the delete face tool, if I pick the faces that I want to remove, bam, gone. It's also a great tool if you get an imported part and it's got a bunch of text or something that the supplier stamped in there, so you'd go to their website and it's just slowing your assembly down. Use delete face, blow that text out of the model, and you can also use it to delete fillets from an imported model. So if you have an imported model, it's pretty simple. You can use the delete face tool with the patch option to remove fillets. So now that I've cleaned up that block a little bit, I need to create one last split line on my part. And this split line is a little tricky because I don't actually have a plane or anything to create it on. So the way I'm going to create this is I've created a new plane through the two end vertices of the edges I'm going to blend together. What this is doing is creating a plane that's roughly normal to or tangent to the curve. So I'm creating a sketch here, and a lot of the times when I create these split line sketches, I'm going to work in 3D because I find it's far easier to pick the vertices and try to going normal to. If I go normal to, I might have to section the model, get me to my right view. But if I work in 3D, I can quickly add the necessary relations. Tangent and to this edge here, tangent. So even though it's just a weird kind of wonky looking shape on this plane, when it's projected onto the model with the split line tool, it's actually a nice smooth line between this edge and this edge. So finally, we all know how we can get all those faces out of the model. We can use delete face to delete that patch out of the model. And finally, surface fill to put it all back together. So here's an example, back to your question, of the difference between delete face and delete and fill. If I had used delete and fill here, if I was able to, because I need contact on this edge, I can't. I'm generating a new face on the model, and I'm not revealing faces that were already present in the model. So here, I've done my right click, select open loop. I pick this top edge first because I know it's contact. And you see that the surface is actually kind of wonky right now. It's just because we're trying to apply tangent condition to an edge that should be contact. Oh, picked the wrong button there. I get contact, and it cleans up my surface. Turn on merge result, try to form solid. Sometimes if you don't see a preview, turning on fix up boundary will allow the surface to complete it. There's little tiny edges that are present along the path of the surface fill. So here I was able to take my convex fillet and blend it into my concave fillet. So just to recap, we're going to use blocks in our model to get the fillets that we can. Yes? We'll get to that in a little bit. I got you covered. So here we need to create new edges, either use splines, lines, and arcs, whatever your design intent calls for. You can use delete face to clean up some of the blocks that are in the model. Finally, we can use delete face to delete the opening, and then surface fill to put it all back together. So who's run into a situation like this, where the part was modeled in such a way that edges should actually flow together, don't end up flowing together? So this edge needs to flow into this edge here. But just because of the way it was modeled for simplicity, I can't actually do that. Oh, we are on 10. So here I'm going to use the fillet tool to get the fillets I can. So I get this fillet. I get this fillet around here. I'm close to having these two edges almost come into each other. Now some of you just may be tempted, if I unsuppress that, to throw as big a fillet as possible onto that edge and say, oh yeah, well we added a fillet, it's kind of smooth, right? Maybe I go up to 1 inch. Oh, it still completes. It's not bad, but if I rotate the model, this could be good enough, but I can still kind of see where my second fillet was applied to the model. So I want a little cleaner transition. Once again, I used my split line tool, and you know where this is going. Delete face with the delete and fill option. This is going to take all those faces out of the model, and where I had two discontinuous sets of edges, I now have one new set of edges where the fillet of one size cleanly blends into the other, and we're in a situation that I couldn't use the variable radius fillet tool just because my starting point didn't allow the two sets of edges to be filleted. So sometimes when you run into these modeling situations, get what you can. Use the fillet tool to add as many fillets to the model as possible. Then you can create a new, smoother transition in certain areas by using the delete and tangent fill option. And here we see our finished transition. We have one fillet smoothly fade into another. So we're going to look at a way we can use the face fillet tool to actually create some blends on our models. So everyone who has ever filleted two tubes that come together know that the intersections can be a little bit off. So we're going to look at this first example where I've applied a constant radius fillet, 0.25 inches, quarter inch. So the quarter inch fillet is actually, the fillet is correct. It's a full quarter inch along its entire length. But visually, it looks a whole lot bigger here than it does up here. So we wanted to have this fillet look visually the same size. One thing I might be able to do, well, I can do it, is use the variable radius fillet tool and apply different sets of radii to various points along the edge. So here I have a quarter inch. Here I have 1/8 of an inch. So to actually make this fillet look visually the same, I have to go from a quarter inch to 1/8 of an inch. And in between, I just had to guess and put some different values in to get something that looked almost the same size along its length. But there's an easier way, and that's the face fillet tool. So because I'm filleting between two faces, under fillet options, it has some options that aren't available to the standard fillet. And that is constant width and curvature continuous. I'm going to turn off curvature continuous for a second. So even though I'm adding this quarter inch fillet along the radius, it's figuring it out how to add a fillet that looks visually the same size all the way along its length. The fillet is the same size, but it's not the same radius. And I don't entirely know how SolidWorks determines what a quarter inch constant width face fillet looks like. As far as I know, just play around with the numbers until you get something that looks like what you want. This would be a fillet you would apply for aesthetic reasons, not for, say, perhaps manufacturing or engineering considerations. The other option is curvature continuous. And so the standard arc or fillet tool uses arcs. If we turn on curvature continuous, it actually uses splines to build the fillet. And we'll look at the difference between tangent and its big brother, curvature continuity, a little bit later in the presentation. So here we use the face fillet tool. We can add those nice constant width fillets to our models that visually look the same size along their length. So let's look at how we can manage this tricky corner. I have a whole bunch of fillets coming into intersection this corner, and I have this nice surfaced indent on this part. So in the example on the left, I've used some surfacing techniques to have a nice clean light line. This fillet looks the same size all the way along its length. And here, I just added fillets to the model willy-nilly, and the fillet is the same size, but because it's between edges that are 90 degrees to each other and edges that are maybe at 45 degrees to each other, it changes in size along its length. So if I were to just add standard fillets in the model, the order I apply the fillets is important. I can't actually fillet these two edges first. Maybe a 50 thousandths fillet here. Nope. Pick this edge, I pick this edge. No way for the software to bridge this tricky corner. So if I did apply the fillets in the correct order, first adding this large fillet, filleting this edge here, I now have a smoother path that the fillet can work its way along. But when I do add the fillet, you'll see that it's two different sizes along its length, and that my light line isn't maintained. It actually gets larger here. So I want to maintain a nice clean light line so I have really nice aesthetics on my product. So let's press this folder. And we know how to stop the fillets, so I'm going to extrude my block into the model. What this allows me to do is add fillets, and I can get that constant width fillet. So even though I'm applying a constant width fillet to two faces that are at 90 degrees to each other, and then a constant width fillet to faces that are almost at 45 degrees to each other, they're still almost the same size, practically identical. For all intents and purposes, they are the same size. So I add the rest of my fillets. I need to clean up this block. So I'm using the split line tool. I have a spline between this edge and this edge. Tangency is applied to both edges. And I can delete from the model. So while surface fill is a great tool, sometimes we ask it to do too much. So I'd like to patch this gap just like we've done in the past. Apply tangency to all edges. And click OK. Whoa, what happened there? So simply, we were trying to do too much with the surface fill. So we need to give it a little more information to work with. So let's suppress that guy. Nice and lumpy surface fill. And we're going to create the portion of the fillet manually with the boundary surface tool. I need to help guide this boundary surface. So I've created a 3D sketch. And in the 3D sketch, I have a spline, and I made it tangent to this edge and this edge. Finally, I use the boundary surface tool. I'm going between these two curves in direction 1, these two curves, and finally I have the tangency applied to the top and bottom edges and the side edge, so that way I know my fillet is going to be tangent. So I need to knit this into the model, and I now am asking the surface fill to do less. So when I create my surface fill, I have a much better example. So if you do see those really weird surface fills, sometimes they'll have big spikes on them, sometimes they'll have lumps, sometimes they'll look like someone kicked in your car door. We need to give a little more information. We were simply asking it to do too much. Yes?
Just curious why it looks like the top of your block that you subtracted, it looks somewhat arbitrary. Why didn't you select the top line of the radius instead?
Because I didn't know how big the block would be until I added the fillets. That's actually a great question. So in this example, I made the block oversize at first to get the fillets that I knew I needed to have. Then I'm going to go back into my sketch and massage the block to be just the right size. And even though, I could have used the split line tool to have that block be nice and straight, but I need the block first to get the fillets. So that's why I try and make it as small as possible and dial it in after the fact once I have the fillets in the model. So we're creating the block, and we're going to try and make it oversized at first, and then we're going to dial it in to the correct size once the fillets are on the model. So here we need to help out the surface fill a little bit by creating the first portion of our light line with a boundary surface, and then finally finishing the corner with the surface fill. So we're going to take a look at some ways we can do some really advanced blends where we have shapes that can't necessarily be created with solid features and the fillet tool. They might require some more complex blends to get to create the correct look. This is the Aluminum Group lounge chair by Charles Rames, designed in the mid-60s. There's a whole range of them. You might have seen the office chair version. It's on TV and movies everywhere. So I'm going to start by creating the transition between my kind of egg-shaped or ellipse-shaped leg and my circular, I guess also leg. So I need to create the outline for my blend. So when I'm doing these kinds of shapes, I always want, actually I'll just jump to PowerPoint to better show this. We'll come back to you in a second. So we're going to model the individual portions of the blend as separate shapes. And then the starting points of these blends could be surfaces or solids, but we need to get just the rough shapes, and we're going to model the blends manually using the surface tools. So a quick discussion I'd like to have about continuity. The continuity reflects how smooth the transition is between two faces. The most basic case of continuity, C0, is where the faces contact each other at a sharp edge, and this is a hard line anywhere on your model. And I'm using the zebra stripes tool to evaluate what these edges look like. Here, in C0, the zebra stripes do not actually flow into each other. They stop abruptly, and you can see that none of the two sets of black lines touch each other. To answer your question of what zebra stripes are, imagine if your part was a perfect mirror finish and you put it in a pitch black room that had a series of fluorescent tubes all the way along its surface. And you could move the part and see how the light reflected off the part. In the second example, C1, or tangency, here this is an example of a standard fillet. C1 tangency means that the rate of change of the curve is always the same. So here we have a standard radius fillet. So we see that the curvature is the same because the radius is constant all the way through that fillet. In C2, or curvature, the radius of the transition is actually changing and it blends smoothly into the curvature of the other shapes. So here we see a hard, distinct line in the zebra stripes because the radiuses of the curves are different where they touch. In C2, the radiuses change along the length of the curve and they match the surrounding surfaces, and you can evaluate that by seeing a much smoother shape. Here they connect, but you have a hard edge. Here they connect and there's a smooth transition. You can also use the curvature display to help evaluate. It's kind of hard to see here, but there's a hard edge curvature between two different faces. C1, or tangency, we have the exact same curvature. The radius is the same all the way along the face. And finally, C2 curvature, we see that the curvature is changing along the length of the surface to match the two outside faces, the green, or the light green and the blue face. So in a lot of these blends, we're going to aim for C2 curvature continuity. Oh, needed to go one more feature down. So here I've created some surface extrudes. The only reason I'm creating these surface extrudes is because I'm modeling one half of the part. When I mirror this thing, I want to make sure it's nice and smooth. I don't have a dimple. I don't have a hard line. And the surfaces I'm going to create need to be made tangent to this, so that way when I mirror them, they're perfectly smooth and flat across the mirror plane. So in my sketch, I had turned my curvature combs on. You can show curvature. So I'm using that to evaluate how smooth my transition is. I've added a spline and use the equal curvature relation between the edges. If I just had the tangent relation, I might actually see a spike here instead of that nice, smooth, flowing shape. And I'm aiming for C2 on this part because it's going to be a high-polished aluminum part. I'm really concerned about the quality of the reflections and the light on this part. So that's why I need to use the C2 relation, curvature continuous, instead of the tangent option. So now that I've outlined my blend area, I need to split edges. When doing these kinds of blends, it's always best to go to an equal number of edges. So this part had 3 edges, and this part I used a plane from this vertex to split this into 3 faces. So I now have an equal number of faces to blend between. So I'm going to create the different faces of my blend. Oh, where did my little handles go? With the boundary surface tool. I like boundary surface in this situation more than loft. Loft does not support curvature continuity in direction 2, where boundary surface does. It will only give you tangency. Loft also has some different terminology. It uses profile and guide curves, but you can think of direction 1 and direction 2 as the same as profile and guide curves, for those of you who are more familiar with loft than boundary. So here, I'm creating my surface between this edge and this edge. It's following this edge. I'm making it tangent to make sure I have a nice smooth transition to the mirror. And then I'm setting, that should be set to curvature to face. If you see this error message pop up, ignore it. I've never seen it. I don't really know what it means. I guess at some infinitesimally small level, the math is saying that it doesn't meet the curvature, but you're probably going to get the right result. I've never really seen it do anything egregious. So I've created the first portion of my blend, and I'm going to create the bottom portion the exact same way. Now I need to knit these surfaces into the model so I have new sets of edges. I could use the boundary surface tool to complete this transition, but I'm just going to use surface fill instead. Either or will work. And I'm setting curvature to all edges. And I've now completed my blend. I took my elliptical shape and I blended it in to my circular chair leg. So to recap, we need to connect the shapes together. We need to outline what our blend should look like. We're going to model the transition by using the boundary surface, using the curvature to face option on these 2 edges. We're using tangency at the mirror plane. And I finally have a second helper sketch to help guide this surface. Then I'm going to use the knit tool to knit my surfaces into the model. Finally, complete the blend with the surface fill tool. So let's look at the Y blend, where we have two legs of the chair coming together and they blend into the central cylinder of the chair base. So these are some of the trickiest blends to get right, but if you approach them with the right strategies, you'll be bound to get good results every time. So let's roll down the tree a little bit, where I actually have two chair legs on the model. Okay, so here, once again, I've outlined the area that I'd like my blend to live in. I have my surface is extruded, so that way when I mirror this thing, I know everything's going to be nice and clean. I'm not going to have a bump or a ridge. And I'm going to model what I know first. I know the bottom of the chair blends in to the other chair leg. I'm not going to worry about what's up top quite yet. So the first surface I'm creating, I only am actually using two directions. I don't have any profile or sketches in direction 2. I have my first edge and my second edge. And the boundary surface has a command called a tangent length. And the default of this is 1. And I don't know why the default is, well, I know why the default's 1, but the result, we can actually see our surface gets a little flat in the middle because we can evaluate it using these curvature combs. I've found that the sweet spot is between 1.2 and 1.4, and it depends on the model and the particular surface you're creating. So I need to increase that a little bit, and I can actually use these to guide the shape of my model. You see, the more I add, or the larger the tangent influence is, the longer the surface is before it starts blending or curving into the other surface. The other thing I've done on this sketch, or on this surface, is I wanted to have the edges, shorter edges. I didn't want to blend all the way between these two whole edges. So the way I did that was I converted the edge. Let's just show that. I converted the edge into my 3D sketch. You can grab the endpoint and drag it back. And then SolidWorks 2014 added an equal spline relation. Unfortunately, it doesn't work on these converted edges. It gives you a warning about fixed shape splines. And then I just added a dimension. And I should have been good, but I was a little lazy. I should have right-clicked these dimensions and unclick Mark for Drawing. That way, if your detailer uses model items, these dimensions that were only used to help define our surfaces aren't brought into the drawing. So I'm starting with what I know. I know that these shapes blend smoothly into each other. And I'm going to model a little bit more of what I know. In order to make sure that the shape is nice and clean, I'm going to turn off. Oh, I'm in the sketch. There is no perspective. So here, I've sketched a spline, and I've used a little known relation that I use a whole bunch and I think is really, really powerful. I'm just going to use a 3D sketch. Actually, let's just start a sketch on that plane again. So I'd like to make a spline curvature continuous to this surface here, but I don't have an edge to add a relation to. So I'm going to lock it onto that edge using the pierce command. And I'm going to select the spline, the edge, and the surface, and I have two new relations that pop up when I have those three things selected. That is tangent face and curvature to face. What this is doing is actually applying that relation directly to the face and not to a spline on the model. So to recap, you need to pierce. This works for also lines and arcs. It doesn't work, or only work on splines, any sketch entity. Select the sketch entity, the model edge, and the surface, and I can apply the equal curvature relation to the sketch. So that's what I've done in this sketch, which outlines what the middle of this transition looks like, where I've added equal curvature to face to this bottom edge and this top edge, and then adjusted the control points on my spline for a nice smooth shape. So I'm going to create the middle of this blend by adding a boundary surface between the outside edge, the middle sketch that I created that's going to help shape that transition, and finally the outside edge. I then added curvature to face to the bottom edge as well. So now this is the trickiest portion. how do I go about modeling this part of my blend? Well, I need to knit these surfaces into the model, because we know that generates new edges when the surfaces are knit in. And I'm going to create one big boundary surface here. It's not what the shape wants to be, but it's going to help guide what the shape will be. So I'm creating the boundary surface between this bottom edge and the top edge. And I have that sketch that I used before to help shape this surface. But this shape is far too big, so I'm going to trim it back. I only need a little portion of the shape in the middle of the Y. So I knit this into the model. Before, you'll see I have this one long edge, and then after the knit, I have a much shorter edge. Finally, I can use the surface fill command on this tricky 5-sided corner. As a rule of thumb, if your surface ends up having 4 sides, use the boundary tool. If it has 2, 3, 5, or more sides, the surface fill is probably going to give you better results. And we'll look at why in just a second. One thing I can't do here is a nice merge result option. If I turn merge result on, that reference surface I had to help ensure tangency also gets merged into the surface fill. So I have to turn the merge result option off. Oh, I guess I didn't turn it off. Oh. And then I can use surface fill or surface knit to knit them into the model. Then finally, after mirroring, let's turn off our line. We see everything's nice and clean. One thing to be aware of, especially when doing this curvature continuous kind of modeling, is a lot of people might just say, well, let's apply curvature to everything. That's the best, right? So apply curvature to all our edges. Wow, we have that kicked in, dented surface fill again. So this is where the zebra stripes can really come in handy. I'm going to start with all of the edges on my surface tangent. Under the evaluate tool, let's turn on the zebra stripes. And I'm pretty good. Even though I set tangency to this edge, I can look at the zebra stripes and see that I'm actually curvature continuous, just like I am on this bottom edge, but it looks like I might need to give a little more direction to the surface fill on this edge here, because these zebra stripes aren't flowing into each other smoothly. So I'm going to click through my edges, look that it highlights them as I click through, find the edge I'd like to be curvature, turn off the apply to all edges so it just applies to the one edge. And now the surface fill is curvature continuous to this edge. The light flows in much more smoothly. So for this kind of Y blend, we're going to start the blend with what we know. The tricky portion is going to be the top. But I know that the bottom 2 legs kind of blend into each other. So I'll do that blending first. Then I'm going to frame the blend. I'm going to use the boundary surface to help give guidance to the surface fill that completes the Y. And finally, I'll use the surface fill command to help patch everything together. And I start out with tangency on all edges, and I use my zebra stripes or my curvature tool to help evaluate the result. I try and keep as many edges as tangent and only use curvature where absolutely necessary. Now, that rule does not apply to the boundary surface, however. If you do want curvature, definitely use curvature on the boundary surface. I could have potentially done one surface fill at this point to complete the whole Y, but if we help guide 2 smaller surface fills, we can get a better quality result, where here we can see that the surface is actually kind of waving. This is an example of asking the surface fill to do too much. Thus, we break it into a smaller problem for it to tackle. So, boundary surface versus loft. When should I use one? When should I use the other? So imagine the outline of the patch you were looking to create as a series or a frame of poles, and you're going to stretch a tarp over that frame of poles. The tarp can be any size or shape and size, but it always has to have 4 sides. You can't have a 2-sided tarp, and you can't have a triangular tarp. You always have to have 4 sides on your tarp. So if I was to try and fit my 4-sided tarp over this frame, what would happen? It would get really bunched up in the corner because I have an edge there and it's trying to taper to nothing, so my tarp's going to get bunched up. The tarp is an analogous to the surface. The surface is actually going to bunch up at this point as the underlying math that generates the the surface all tapers to 0 here. And this is going to lead to problems with the shell tool, with offset, and potentially adding fillets. So instead of trying to jam our 4-sided tarp into our 2-sided frame, what if I draped the tarp over the top and then trimmed it out? And this is actually what surface fill is doing. It's taking a big 4-sided surface, draping it over your framework, it could be considered your surface edges, and then trimming it back to fit the boundary. So if your tarp is going to be 4-sided, boundary surface or surface loft is going to probably be the way to go. If you have a much more, or either simple 2 or 3 edges, or 5+ sided, the surface fill is the way to go because its ability to trim back. So this is the actual what the surface fill looks like. You can actually see that the lines, the math of the surface is kind of a square grid, whereas the math of the boundary surface actually follows what the outline of the frame looks like. And these are just edges that I've converted and just made a little cleaner for you to see. So if you have 2, 3, or 5-sided surface, use surface fill. And to answer your question about optimized surface versus surface fill, optimized surface on just automatically generates a loft or a boundary surface, and it's always going to be 4-sided. Turning optimized surface off creates this larger 4-sided patch and then trims it back to fit the X number of edges that are present on your model. Sometimes it happens in the background. I don't know when it decides to do or a 4-sided surface or not. The one difference you'll see on the graphics window, and we can roll up, there's a good example of it here. Let's turn off our zebra stripes. This guy. So here's the 4-sided surface. You can actually see the grid outline of that large 4-sided surface. Turn optimized surface on. Odds are with tangent, it's not going to figure it out. But here's an example. If I set everything to contact, you'll see that it's actually generating that 4-sided surface and fitting it within the framework. With it off, generates the 4-sided surface larger and then trims it back to fit the opening. So sometimes surface fill doesn't work. And it's maybe 5% of the time, but sometimes you'll get an error message. And there's some ways we can resolve that. So I'd like to create a surface fill here, patch this, big gap, select all my edges. And the surface fill will actually complete if everything was set to contact. But if I set everything to tangent, I don't see a preview, I click OK. It says the patch cannot be created. Try a different curvature method, alternate face, or surface quality setting. This is, an example of the surface fill trying to do too much. So we can make its problem a little bit easier by creating a new boundary surface in the middle of our opening and then 2 separate surface fills. One thing when you go to create this surface, is that because the edges are much longer, sometimes when you click them, you might see a preview that looks like this. If that's the case, right-click and flip connectors, and that's going to realign them. You can also drag these connectors on the model to shape the size of your surface. Note there's no way to add dimensions to this. Everyone email your VAR, say, hey, add the ability to add dimensions to these connectors because it would make life a lot easier for some people. So here, create the boundary surface.
They'll snap the points though, won't they?
Sorry?
They'll snap the points though.
Sometimes they'll snap the points. It's hit and miss. It should be able to snap the points. The literature says it's snap the points, but yes, it will snap to splits along, like it will snap to the edge here, but there's really no kind of point. I can't say I would like it to be vertical between these two, or I can't say I would like it to be a ½ inch from this edge. I believe it uses percentages along the edge to position them when you have rebuilds.
Couldn't you use a 3D sketch?
That's exactly what I had done. This was just in the last example where I convert to the 3D sketch. Here I'm just saving that step. I don't have to convert edges. I can just drag back. This surface really just needs to be a small little surface to help give a little more information and split up the problem for the surface fill. So here we need to make the blend surface fill area smaller. We use a boundary surface for that. The final kind of blend I'd like to discuss today is the washout. So the washout refers to a type of transition where a hard edge seamlessly fades into surrounding geometry. Next time you're stuck in stop-and-go traffic, look at the bumper of the car in front of you. Odds are it's got some kind of washout where there's a hard edge and it fades out into nothing. And you'll see this all over the place in automobile design, consumer product design. And while it's common, it can be one of the trickiest blends to get right. The way I go about modeling these transitions, so here we can just rotate the view. We see that our chamfer seamlessly fades out in the surrounding geometry. Turn our edges on and let's roll back to the first feature. So I've just created an arbitrary surface. It is curved in both directions, in case you were wondering. And the first thing I do when creating these kind of transitions is a layout sketch. For my layout sketch, I'm adding dimensions that will, so I can, if I need to change the washout in the future. I have some lines. I have my splines that are curvature continuous to the lines. And when I create future features, I need to make sure I convert the entities from my layout sketch into the new sketch so that way the layout always stays at the top of the tree and doesn't end up getting absorbed. So what I need to do now is trim out an opening for my recessed surface that's actually going to be a little bit behind the first surface I created. We see that there's actually a bit of an opening. So this surface is once again a boundary. I created a plane, added a sketch with a spline, used the equal curvature to face option. Here I'm creating the boundary surface with this edge to my sketch. And I'm using the top edge, but I'm not setting any end condition to it because mathematically, if this edge is curvature to face, which it is because I trimmed it out, and my new spline is curvature to face, the surface will be curvature to face all the way along that length. Sometimes you may need to increase this slider called tangent influence. If I look at my surface, and I look at the curvature cones, which I'm going to use to evaluate the quality of the surface, by increasing it to 100, it actually tames out those spikes. And what that is doing is giving more preference to the shape of this portion through the resultant surface I'm creating. You can actually kind of see how the surface changes. It almost looks like it dips in there, whereas there it punches back out because it's giving more preference to this shape. So I now have my recessed surface, and I need to trim out the area for my chamfer. And once again, I can convert entities from my layout sketch. I use the surface trim, and I'm now knitting into the model. So I have my recessed surface, and I have the area that my chamfer is going to live in. So I'm creating the first portion of the chamfer with a boundary surface. I created a 3D sketch just as a nice little reference between these two vertices. It's just a line sketched between them. I'm using edge 1. And note that I'm not setting the curvature to face option. Because the two curves in direction 2 become curvature to face here, there's no need to set that. So I'm going to add the second chamfer. I'm going to use the surface knit to knit into the model. And finally, I'll finish the corner with another boundary surface. Once again, I'm using the curvature on these edges, and I don't need to use any relation or end condition here because we want a hard edge on our chamfer. So I can knit into the model, and I'm mostly done the washout at this point, but maybe I'd like to add some fillets so that way I don't have super sharp edges. The way I'm going to do that in this example is actually trim out an area for the fillet. We could use some of the techniques we've learned today by adding, maybe cutting out portions of the model, trying to add standard fillets. So if I were to add a fillet, I might be able to get it. But the fillet tool is going to struggle here just because this edge is becoming tangent to this face here. So I find in these kind of situations, I'm going to trim out the fillets. So my sketch is just a series of offsets from my layout sketch. It's kind of to define the size of my fillet. This is also going to create a nicer looking constant width fillet in our transition. So there's two ways of going about adding the fillet. If I want to add the fillet in one long big feature, which is fine 95% of the time, I need to use the selection manager to select a series of edges or convert the edges into a 3D sketch. But the selection manager works by right-clicking, bringing up selection manager, and it has this nice little tangent button so I can grab all the series of tangent edges in the curve. So I use Selection Manager to select more than one set of edges. Sometimes it doesn't give me the tangent pop-up and I have to pick them manually. So I now have two open groups in my model, and I'm creating the transition between them. I'm setting curvature to face. But one thing that's very important when doing this kind of filleting, don't pick these edges. The reason for that, let's pick these edges. Just by adding them into my model, look what's happened. It's now trying to force that series of edges all the way along our fillet. And if I were to take them out, I have a much cleaner looking fillet. There might be a tiny, tiny mismatch at this corner, but the surface knit is able to deal with that gap, and it eliminates it when it's knitted into the model. So sometimes when trying to create these fillets all in one feature, you can have some poor results. So you can do them face by face, just like the standard fillet tool would create. So I've created that boundary surface again, but if I zoom in, the end of my surface is actually a little crooked. It's almost spline-based. So to create a cleaner transition, I'm going to do a cleanup. The order of operations on the cleanup is important. So let's roll back here. The first thing I need to do is create a sketch to trim with. And I'm making it coincident to this line, or that vertice and this vertice. I now need to trim it back, but if I were to go normal to this sketch, wrong side again, we'll see that the surface is actually too short. So I need to use surface extend, but I need to put the sketch first so that way I have the vertices to make the relation to. Finally, I use surface trim to clean it up. I can knit these into the model and finish the boundary surface. So the example of making one long continuous fillet with one surface, it's going to be good a large majority of the time, but sometimes you just want to be a little bit cleaner, so you're going to model each face of the fillet step by step. So to recap, we're going to create that layout sketch. It'll help us define the rest of our features. We need to create our window for our recessed surface. We model that recessed surface so that way we can actually create the chamfer between something. We're creating the surfaces of our chamfer using the boundary tool. Then finally, we're splitting out an area for the fillet, and then we're using surface tools to manually build the fillet. And we knit everything together, and our washout is finished. So, still won't fillet. Now I'm going to end on this, and this is a surefire way to add a fillet to any model 100% of the time, guaranteed. And you may say that's a lofty claim, but bear with me. So here, I'd like to add a fillet to this bleach bottle. Now, I'm calling this a fillet from hell because the fillet tool has no chance here. We have different areas of almost tangent surfaces. Down here, the fillet tapers to nothing. In here, there's two different sets of edges that it might not know how to bridge in this area. So while we could have used techniques discussed previously, we could extrude blocks in the tricky areas, we could get the fillets we need, there is a better way. So what does the fillet tool always generate? Well, it generates two new sets of edges with a transition in between them. So it would be able to create these edges with a series of split lines like I did in the last example. But on the bleach bottle, it's going to be difficult. It might require a whole bunch of split lines on different planes just because of the shape. So here we see the shape. See, it's one long, big fillet, and the fillet tool is probably going to have some problems here. You know, if you don't believe me, let's try and add a fillet. Point one. It's going to think for a while, and we all know the outcome here. Fillet tool isn't going to be able to add anything. So I'm not even going to bother and waste everyone's time by clicking OK. So the way to add the fillet to this edge, create a sweep. And this sweep is created with a 3D sketch. What I've done is converted every single edge into the sketch. But what I've done is used fit spline, which is a drop down here. What fit spline does is take a series of edges in a sketch and put one big, long, continuous spline all the way over the top. And it converts the original edges into construction geometry and gives us one smooth spline. The reason we do that is see how the sweep is created with one long, continuous face? It isn't a series of faces along its path. So I need to do a little bit of cleanup work with my sweep. The way I define the radius of my fillet is with a circle that I've sketched. So we're going to extend the bottom face here. I'm using a ruled surface to cap it off. So I have one closed cap here. That way I can trim. And finally, use a standard trim with the swept surface as my trim tool, and I'm going to just pick the body and select Keep Selections. So use Body Delete to delete the no longer needed sweep surface. And what do I have? 2 new sets of edges on my part that I can create the transition with. Just like we did in the last example, I use the boundary surface to add my fillet between faces on the model. One thing to be aware of is the use of connectors to help shape the surface. If I right-click and reset the connectors, see the preview? The surface is actually jumping over itself on the bottom of this U shape. So you need to add some connectors by right-clicking an edge, add connector, to help kind of guide it through the tricky areas. And you'll know you've added enough connectors. You might need 2 or 3 when you see the preview look far more like what you intended than it did before. So here's my large portion. And just because of how large this fillet is, I'm going to create it in different sections. I knit them into the model, and I finally finish with a few different surface fills. So a disclaimer, do this at the end of the tree unless you have to have it in before the shell, because if you have design intent changes, odds are this will not survive rebuilds, and it can be a pain to try and repick all your relations. But it is a surefire way to add a fillet to a model 100% of the time. And we're doing that by creating our sweep of a circle along the part. Our sweep path is a 3D sketch, and we clean up the 3D sketch by using the fit spline to have one long continuous edge. We cap the ends of the surface fill, and then we trim it back. And if you were starting with a solid body, I was modeling that bleach bottle wall with surfaces, you could use a solid cut sweep and then delete face to turn the model into a surface model. We're going to build the fillet faces with the boundary surface tool, and finally complete the fillet with the surface fill. And that's it. We're all done. A surefire way to add a fillet to a model 100% of the time if you get that stuck. So I thank everyone for coming and listening to our presentation today. I hope that you've learned something. You'll take it back to your company, and maybe it'll help you get out of the office a little bit earlier on Friday when you're stuck with that really, really heinous fillet problem.